Example 3. Example 3's function says f of x equals ax squared. So this is not going to be a horizontal shift or a vertical shift. This is where the graph is going to get wider or narrower. So a key point is that if the a value is greater than 1, which means it's a whole number or it can be an improper fraction, the graph will get narrower as it approaches the y-axis, which means as it approaches the y-axis, it's going to approach the y-axis getting skinnier. It says if the a value is between 0 and 1, which means it could be 1/4, 1/3, 1/7. It's a fraction that is normal. That means if I were to do it, it's going to be valued less than 1. The graph will get wider as it approaches the x-axis. So think of it as a flower opening up and blooming to the sun. So our three functions are f of x equal to x squared, g of x equals 2x squared, h of x equals 1/2 x squared. In this type of situation, if they are asking you to graph three functions on the same function point, pick numbers that are going to be easy for you to graph. So what I'm looking at my g of x function, and I'm looking at my h of x function. Since the h of x function says 1/2, the number I want for x has to be something I can take half of. So instead of using -1, 0, and 1, for the parent value, I'm going to use 2, -2, 0, and +2 to start. So if I have -2 and I square it, I become a +4. 0 squared is still 0. 2 squared is a 4. The reason I did that is now we're going to use these values into this equation. So we have, again, we're going to use those numbers. This one requires you to do your t-charts for all of them. So I'm going to put my -2, 0, and 2 again. Now it means I already know what the answer for plain x squared is. I'm going to take my answer and multiply by 2. So basically we're doing 4 times 2 and we have an 8. 0 times 2 and we have a 0. 4 times my 2 and we have an 8 again. When we go to this one, same situation. We're going to use the -2, 0, and 2. Now we're taking, think of it, it says half of x squared. So our solution was a 4 originally. So I'm going to multiply times a half. Half of 4 is a 2. 0 times a half, we are still a 0. Again, 4 times a half, we are a 2. So first thing I see is my ordered pairs became -2, 4, 0, 0, and 2, 4. That is our parent. The second one, notice that the value of a is greater than 1, so it means the values are going to approach the y-axis faster because it's approaching at a faster speed. Here, the 1/2 x squared means it's going to open up closer to the x-axis. Now, if we go to graph these on the parent graph, since my highest value for the y is an 8, I need to make sure that my graph grid goes up to an 8 at least. So I'm drawing in my graph lines. Because remember, what's affected is the y value, not the x value in this situation. So I have a greater quadrant 1 and 2. Label your axes, x and y. So the first one, the parent graph, our parent, it's -2, 4. So I'm going to go to -2 on the x and up to 4. Put a dot. Still at the origin, 0, 0. And then mirror image. So if I'm 2 units out from the y-axis, I'm going to be 2 units out on the other side of the y-axis and sketch your graph line in. Now we're going to have a great curve here when you're doing freehand. So if it looks like a V, don't worry. On the next one, it says -2, +8. So the x value did not change. It's the y value. So right here I'm at 4. So I'm going to go 5, 6, 7. That's +8 here. Still at the origin. They share the same origin. 2 units out. 2 units out. Sketch your line in. That is our g of x. Don't forget to label your f of x, your parent. Now, when you go to the last one, it says negative 2, 2. So negative 2 stayed here. Here's my 2. It's still at the same origin point, 2 units out. And then our graph line comes in. And we have h of x. So the more our x values increase here on the parent, on this last one, the h of x, the more the parabola is going to keep approaching the x-axis. On the g of x, the more x values we incorporate into our thing, our graph keeps getting closer and closer to the y line. You're probably wondering why we did the first 3 examples. That leads us to example 4, where it's f of x equal to a parentheses x minus h closed squared plus k. This is the vertex form. So example 1 started with a vertical shift. Example 2 started with a horizontal shift. And example 3 required us to have an a value. Now we're tying it all in together to get to the vertex form. So our problem says f of x equals 2 parentheses x minus 3 closed squared plus 4. It says identify the vertex. One thing we need to remember for the vertex, that is h comma k. Well, if we look at our equation, h is the value inside, k is the value on the outside. But we know that when we see x minus 3 and set equal to 0, x is equal to a positive 3. So we know the x coordinate is a 3. The k value stays as is, as it's 4, positive 4. I'm going to use a 4. So there's our vertex. Part B says to identify the axis of symmetry. From the beginning of the notes, I said that the axis of symmetry, it's the same as the x coordinate of the vertex. So our axis of symmetry is x equal to 3. Then it says, asks us to identify the max and minimum value. The max and minimum value, this is known as the y coordinate of the vertex. You will use the y coordinate of the vertex. So since our y coordinate is a 4, our value is a 4. Now here's the thing, we need to know, do we have a minimum or a maximum or a minimum? So in order to find out if we have a max or min, look at your a. Well, it's equal to 2, which is a positive number, which means our graph is going to open up. So we have a minimum value. The next part that we need to do is actually graph our equation. So let me switch and get graph paper and we'll continue. Okay, so we have our function as f of x equal to 2 parentheses x minus 3 closed squared plus 4. Let's remember our key features. The vertex is 3, 4. Our axis of symmetry was at x equal to 4. Our minimum value is at y equal to 4. Actually, x equal to 3 here, sorry. And then y equal to 4. So in order to graph this, you have 2 options. You can graph the parent function, which is what I would do, and then do your shifts. So for this one, normally our parent function would be f of x equaled to x squared. But because we already have an a value, I'm going to use f of x equal to 2x squared to be our parent. And then from here, we're going to do our shifts. So I'm going to do an XY table. And I'm going to start with basic -1, 0, 1 in this instance because it's a whole number. I don't have to worry about fractions. So -1, so basically think of it as 2 times -1 squared, which is a now positive 2. 2 times our 0 squared makes it 0. 2 times our 1 again squared makes it a 2. So this is our parent function. This is what we're starting at. Coordinate grid. label your axis, X and Y. We're going to start with our first parent one, which is -1, 2. So we have a dot at -1x, positive 2y, 0, 0, and then 1, 1. So this is our, we're going to say this is our parent. I'm going to call it P of X to represent parent. And now we're going to graph our actual graph. Now, from here, we're going to have to do our shifts. So let's look at our vertex. Vertex value is x equal to 3, y value is equal to 4, which means we are going to go to the right 3 and then up 4. So each of our dots are going to go to the right 3, so we're going to go up to the right 1, 2, 3, up 4. 1, 2, 3, 4. The vertex point is going to go to the right, 1, 2, 3. There's my x equal to 3, up 1, 2, 3, 4. My y component, there's my vertex at 3, 4. And the same thing here. So 1, 2, 3, up 1, 2, 3, 4. They should be mirror images. And then you do your curved. So this is our function there. There's my f of x. Now, axis of symmetry, remember, it's an imaginary dashed line going through the x coordinates. So here's my x coordinate, x equal 3. So you just have a line, a dashed line going through it, representing our axis of symmetry.